Hi, I'm recording. Yay! This is my first video that I wanted to record for you. This is on the ideal gas law. More specifically, we are going to be applying this question to your UT Quest homework 11. There's a question on the gas law on there. If you've read your textbook, also you've seen a couple equations. So let me explain. The ideal gas law is PV equals nRT. I'm pretty sure that you know that pressure, P is pressure, all right, and that unit is in pascals. V is clearly volume. That is actually in meter cubed. It's not totally intuitive. T is temperature, and that's going to be in kelvins. N is number of moles. And then finally, R is what's called your universal gas constant. Value of that is always the same. It's 8.314 joules per mole times Kelvin. That means that both of these terms are in the denominator of the fraction if you're keeping up with your units. Interestingly, often in physics, this equation has a slight variation where instead of using number of moles, N, a lot of physicists will be using number of molecules because quite frequently physicists work on a much smaller scale. In that case, the equation is rewritten as PV equals NKT. It's really the same equation, just slightly different. Instead of little n, okay, being number of moles, this big N is actually number of gas molecules. All right, and this little k is what's called Boltzmann's constant. It is 1.38 times 10 to the negative 23 joule per Kelvin. All right, so I just wanted to explain that to you. It's essentially the same equation. It's the ideal gas law equation. Just now you're using number of molecules versus this one right here, okay, which is number of moles. The question that we are going to attack on the Quest assignment actually gives us the number of moles. So let me tell you on my problem for my Quest question. All right, for my question on Quest, it is asking what is the volume in liters of 2.1 moles of gas with a pressure of 3 atmospheres and a temperature of 0 degrees Celsius. So again, this is not that big of a deal. But in order to solve this problem using this equation, I need to have pressure in pascals. It's not. It's in atmosphere. And I need to have temperature in K, in Kelvin, and it's not. It's in Celsius. So let's start making these changes here. It's very simple that for every 1 atmosphere of pressure, that actually equals 101,300 pascals of pressure. That's not 0.1, sorry, that's for every 1. 1 atmosphere is typically what we live in. You know, pressure goes up and down. That's the purpose of a barometer. Pascals, because it's got more digits, it'll give you a much more accurate reading. But, you know, typically, of course, we usually say millimeter mercury in standard. But looking at this problem right here, the SI unit is, in fact, the Pascal. So I can either look it up on Google, how many pascals is 1 atmosphere, or you can do your very simple dimensional analysis. So I'm going to start with what I'm given, which is 3 atmospheres. Okay, and I'm going to say, well, I need atmospheres to cancel. I know 1 atmosphere is 101,300 pascals. Okay, so once I do that multiplication, I can actually cancel out my units. Then I will find that I get 303,900 pascals. Okay, for the unit I'm going to substitute in. Temperature is super easy. You just always take, if it's in Celsius, you always take the Celsius and add 273. Okay, and that implies your temperature in Kelvin. So right here, I'll use red. This is 273 K. It's not degree Kelvin, it's just K. Finally, now I can start to go ahead and solve this problem. I know that PV equals nRT. I'm solving for V because that's what they asked me. Right, so what is your first step to get V by itself? All right, so I'm hoping you answered correctly. To get V by itself, your first step is you are going to divide both sides by P. So now you will have your volume. So this implies that your volume equals nRT over P pressure. Great. I'm going to start substituting in my values. All right, this implies that my volume is equal to, N is 2.1. I'm just not even going to mess around with the units right now. They're important, but I'm going to prioritize working the problem. 8.314, all right, times my temperature, which is 273, divided by this humongous number 303,900 pascals. I'll write Pascal, but don't worry about the unit. Go ahead and calculate that. What answer do you get? On top of that, what unit is your answer is what I would like to know. What is your answer and what unit? Okay, so the answer should be 0.01568 meters cubed. All right, that's not very convenient for us because the question wants the answer in liters. So, next step. You will take this and convert to liters. You can either go to Google and look it up, or you can say 1 liter is equal to 0.001 meter cubed. All right, that's a fact. It's just, that doesn't change, that's just actually true. So if I want to, I can go ahead and make that conversion. Right, times our conversion factor. Well, I need meters cubed in the bottom, so I put 0.001 meter cubed is 1 liter. Those two little guys cancel, and my final answer is 15.68 liters. Yay! And now I'm hoping that after you've followed this video, you will be able to work this problem on your quest. Yay!